let's practice another one. How about now f of x is the function. F of x equals x cubed minus 10x squared plus 16x. We'll solve f of x greater than 0, and we'll solve f of x greater than or equal to 0. So first, when is f of x equal to 0? Okay, again, this polynomial inequality, too many things going on. Let's just get a 0 on one side. I guess, yeah, there's already a 0 on one side of the inequality. But let's solve the equation to go back to the inequality after, because it's only in the equation that we can apply the zero product property. So we'll set this f of x, we're replacing the f of x here with this here, e equals 0. The left side, I get that it's a degree 3, x to the third, that's the highest power. 3 is the highest power, but we can factor out an x out of all terms. And then inside parentheses here, that will factor further. Then apply the zero product property, and you'll have x equals 0, or x minus 2 equals 0, or x minus 8 equals 0. We skipped writing that step just to have x equals 0, or x equals 2, or x equals 8. Great, that solves the equation. Now we can go back to the inequality. To talk about f of x greater than 0, or to talk about f of x greater than or equal to 0, we need this sign chart. So without going through all the details this time, you'll see here, imagine it, visualize it. 0, 2, and 8 are the places on the number line where y is equal to 0. Then we've created x intervals of negative infinity to 0, an x interval of 0 to 2, an x interval of 2 to 8, and an x interval of 8 to infinity. And then for the factors, so here's f of x right here, highlighted there, x times x minus 2 times x minus 8, written in a factored format. That's the same as this here. We've written down the individual factors of f of x, and here's, I guess, f of x written again in a factored form. And we analyze whether each factor is negative or positive. So you got to go through, make sure all of these symbols are correct. And then a negative times a negative times a negative is a negative, and a positive times a negative times a negative is a positive, and so on. So based on what we see here, we can look at the plus sign that appears there, and answer that f of x is greater than 0 when x is in this 0 to 2 interval and in the 8 to infinity interval. What about f of x greater than or equal to 0? Well, now we just need to include the x values of 0, 2, and 8. So that's just a moment ago we had excluded those because of the parentheses. Now we include. There's a bracket around the 0, bracket around the 2, bracket around the 8. Now as a bonus, we can actually answer, it wasn't up in the question, but it's not much really, because we've done all the hard work here. We can answer when f of x is less than 0. So when is the y value negative? It happens when x is in this interval, and again, y is negative again when x is in the 2, 8 interval. So there, we just wrote it there. As another bonus, we could graph. Now, it wasn't in the question, but just because the point is the minus plus lets you know what part of the graph is below the x-axis, what part of the graph is above the x-axis, or where is the y value negative and where is the y value positive. Okay, so just to highlight it here, right? The graph is above the x-axis when x is in these intervals, and the graph is below the x-axis, or the y value is negative when x is in these intervals. You can go ahead and click on a picture here. Let's do that to see what the graph here looks like. Okay, here's what happens when you click on the link. Sorry, the picture is kind of a bit squished, but don't worry about how high you have to draw this peak and how low this goes. That doesn't matter. The key point is that you should see what parts of the graph are above the x-axis and which parts are below the x-axis. And by the way, instead of in this format, if you want to see the factored format, it's the same. So the blue picture is residing in the same space as the red picture here. Okay, note to solve x cubed minus 10x squared plus 16x greater than 0, the one that we just looked at, we first looked at the equation. Right? We first turned the inequality into an equation. In the equation, you really want to equal 0, so same deal in the inequality. I guess it was already presented with a 0 here, but let's just say that the 10x squared appeared on the right side as a plus, then you'd subtract it on both sides first. Okay, we looked at the related equation first, and then we factored because we wanted to apply the zero product property. The zero product property does not apply to inequalities. That's why we had to look at the equation. So while you could take the inequality at the top, you can technically factor the left side, that's fine. You can have x times x minus 2 times x minus 8 is greater than 0. That's fine, but you can't turn that into x is greater than 0 or x minus 2 is greater than 0 or x minus 8 is greater than 0. That is attempting to use the zero product property on an inequality, which is invalid reasoning. You can never take, even though you have a 0 and you have a product, the zero product property was never for inequalities. It's only for equations. So this is an error, what's written in red. Turning what's in black here, which is technically fine, but I wouldn't do it because it's just going to lead people into this error. The whole point here is when you have a polynomial, so the degree is like 2 or 3 or something like this, and an inequality, to break things into some pieces and to break up the number line and draw the sign chart, you got to convert to an equation for a moment just to see where the roots are so that you can see where the number line breaks up. Okay, again, the zero product property does not apply to inequalities. That's why we looked at the related equation. That's why we took this inequality and we looked at the equation. The equation let us break things down so that we could see x equals 0, x equals 2, and x equals 8. And then we could say, oh, if the number line is cut right at x equals 0, at x equals 2, x equals 8, then we can build a sign chart out of the 4 intervals created by the 3 cuts. So this is, just to outline it, a general procedure for polynomial inequalities or polynomial graphing. Get all the terms on one side. That is, you want to make sure you have like a greater than 0 or a greater than equal to 0 or a less than 0 or less than equal to 0. Even if it doesn't look like that, just add and subtract terms so you have a 0 on one side. Then solve the related equation. Just for a moment, temporarily convert the greater than sign or the less than sign or whatever into an equal sign. That way you can do the zero product property. You got to factor and all that business. But then that's going to allow you to create the sign chart. And based on the sign chart, you can answer the inequality, and also based on the sign chart, you can graph.